and wear resistance. Corrosion resistant composite materials, primarily fiber reinforced polymer like carbon fiber and glass fiber, are used for naval platforms to enhance durability in harsh marine environment. Materials are supplied by Midhani, HL, Forge and Foundry, and private industries like PTC Industries and Kerala Minerals, etc. Certification and quality assurance. Components used in aircraft are required to meet stringent safety and performance standards to ensure the reliability. Certification and quality assurance requirements are critical aspects of additive manufacturing in aviation applications. International standards such as AS 9100 Delta, ISO 9001, and NADCAP, which is a National Aerospace and Design Contractors Accreditation Program, are followed by industries in the field of aviation and aerospace. These standards define the requirement for quality management systems, process control, and testing procedures. Certification of military aircraft components in India is governed by Center for Military Airworthiness Certification, that is CEMILAC. CEMILAC has taken various initiatives recently to ease and streamline the certification process, like issue of certification kit for the industry and online certification portal for benefit of the industry partners. The guideline documents to be referred during the process of certification are as shown. Both the reference documents have been issued by CEMILAC for the benefit of aviation component developers. IMAP 2023 includes the global best practices in airworthiness certification, and IMTR 21 covers technical airworthiness requirements for all phases of development life cycle of airborne stores. Despite its tremendous potential and great benefits over a conventional manufacturing process, additive manufacturing faces several challenges. The major challenges that need to be addressed to achieve widespread adoption of additive manufacturing are as shown, like high cost of equipment and materials, limited availability of aviation grade materials within the country, skill gap and lack of trained manpower. Certification process is still evolving. However, despite present challenges, due to its excellent benefits over the conventional manufacturing process, additive manufacturing is projected to reach $100 billion by year 2030 and growing at over 20% CAGR. Also, Government of India has been promoting research and adoption of latest technologies like additive manufacturing through academia, centers of excellence, and industry partners. GUI initiatives. Now, I would like to take this opportunity and highlight the efforts of Indian Navy to engage with industry partners. In accordance with initiative of Government of India, Naval Aviation has projected the requirement of indigenous development of more than 400 by-type aircraft items on Srijan Defense Portal for reference of prospective industry partners. Based on interest from various industry partners located at different parts of the country, Directorate of Air Projects and Plans and in-house indigenization committees of naval aviation at Goa and Kochi are engaging with the firms to progress the development of aircraft spares. In the end, I urge the industry partners to engage with Indian Navy and naval aviation for indigenous development of aircraft systems and components. With this, I finish.
Thank you, Commander Gadge, for your perspective on the benefits of additive manufacturing that the naval aviation has accrued and what it holds in future for the Indian naval aviation arm. So, ladies and gentlemen, we've got just about 12 minutes wherein you can pose questions to both the speakers. I would request you to kindly identify yourself and also indicate as to whom you are posing a question to. So the floor is open for questions. The gentleman at the end, please.
Good morning, esteemed panelists. My name is Sachin Yadav and I am from Indian Council of World Affairs. My question is for Gopiji sir. Sir, as we all know that the navies around the world has to be in ocean for a longer period of time. Now, due to which, if any defect comes in the ship has to face a delay because the spare parts has to deliver through the ocean. Now, what most of the navies, especially US, has done, they have started deploying onboard additive manufacturing units so that they can decrease the delay. So, does India has also taken these kind of steps?
Oh, I don't know, but in future they are able to do because majority of time what they are doing when I visited UK that time, they are putting the printers inside the containers. Okay, even for army, anything inside the container they will print the part, but it will going to come soon in India also. But India as of now, maybe our Indian Navy can.
Yeah, I'll answer this question because we did make a foray into this, but the issue which is faced on board a ship, as he rightly said, that the printer is placed inside a container, but the issue with the ship is you need a stable platform for doing the additive printing, right? When the ship is rocking, unless you provide the, stabilization to the container, you would not be able to do it. So as of now, if you ask me, it is not being used. Yes, going forward, and if you've got containers which are stabilized, you should be able to do it.
Good afternoon. Thank you very much for your informative presentations. My name is Rahul Rajhe and I belong to an organization called Fronius India Private Limited. It is not typically a question, but I wanted to just mention one point that all along since morning we have spoken about only one method of additive manufacturing, and that is LPBF, laser powder bed fusion. When it especially comes to bigger part printing for defense applications, may it be Navy, may it be Army, there is one more method called DED, direct energy deposition with welding arc and wire. I think Gopi sir would know because DRDL has been working with us. We are working rather with DRDL, ISRO, that is VSSC, HL, everybody for this. And if you see globally, bigger parts are being printed as big as, say, propellant tanks for satellite launch vehicles. There are 3-4 companies in USA who are doing this, Relativity Space, even SpaceX and all, they are doing, and now ISRO is also trying for doing that. We are working with VSSC very closely. Again, the materials, all ferrous and non-ferrous materials, whichever can be drawn into wire, are printable with this technology, wherein there is a welding power source with typical additive features, additive characteristics. There is a 6-axis robot, 2-axis positioner, and a toolpath planner that completes the system, and then you can print it. The biggest advantage of this particular technology is, especially for printing bigger parts, is there is no other technology of additive or process of additive wherein you can stop in between and print again. Once you start, you have to complete it. May it be polymer printing, may it be plastic printing, may it be metal printing to LPBF. But in DED, you can literally print a part, stop after one layer, let it cool down a little, let fusion happen, again start. So it gives us immense possibilities to print bigger parts over a period of time. We have already done a lot of work. So anybody wants to know, you can connect with me. We can share some knowledge on this. Thank you.
Yeah, thank you. Anybody, any question? So no question. All that remains for me is to thank both the panelists for very insightful talk on their respective topics. I thank the audience also for keeping awake and it becomes very, very difficult immediately after lunch to be attentive and to keep awake. Thank you, ladies and gentlemen.
Thank you, Chair and panelists, for such an informative and interesting session. May
Well,
I now-
before we end, ma'am, I have a question. If somebody, we have a lot of companies present here. Well, when you're doing, manufacturing of certain critical components, let's say blades for the gas turbines, and when we are doing specially for the turbine side, which are subjected and exposed to very high temperatures, we are going for, single crystal kind of technologies where we are controlling the grain structure of the material. Is it possible with the present advancement in 3D printing or additive manufacturing to be able to control at the grain level and ensure that we get, we are able to manufacture the turbine blades using additive manufacturing?
Yes, sir. It is perfectly possible to print turbine blades with DED with welding arc and wire. You can absolutely control the grain structure, may it be Inconel, may it be any other material, even margin steel. We have done it. We have printed some propellers also in Inconel, in stainless steel, in carbon steel, all three metals. It is perfectly possible. As far as the qualification is concerned, American Welding Society, AWS, has got specific standard development done for this particular method, which qualifies the process, which also qualifies the operator.
Thank you.
Yeah, just to add on what Rahul had mentioned, for polycrystalline materials, yes, to a certain extent, but I take your query for directional solidified turbine blades and single crystal blades. On that, to certain volume build, it is possible, but if you see for like gas turbine engines require, to that level, I think it is not there as of now.
What my information was also there, and certain discussions with the Indo-MIM and others. So they told me the work is in progress. As of now, we've not achieved
Yeah, full volume build is
perfection.